Welcome back. So in this tutorial, we are going to be solving this leet code question, count nodes equal to average of subtree. We're given a binary tree and we're told to return the number of nodes where the value of the node is equal to the average of the values in a subtree. So for example, for the node with value of 4, the average of a subtree is 4 plus 8 plus 0 plus 1 plus 6 plus 5. And we divide that by the number of elements in that tree, which is 6, and that gives us 24 divided by 6, which is 4. For the node that has the value of 5, we find the average of a subtree by adding 5 plus 6 divided by 2. And that gives us 11 divided by 2, which is 5, rounded down to the nearest integer. And the same thing goes for 8, the node with 8. But when we do the average, we don't get a value that equals to 8. For example, we are going to be having 9 divided by 3, which is 3, and 3 doesn't equal to 8. When we do the average for the node that has the value of 0, we have 0 divided by 1, which is 0, and is equal to 0. So essentially, all the items in all the nodes with the blue color are the nodes that have the value, the average of the values in the subtree to be equal to the value of the node, which is 5 in this case. So we can solve this problem by traversing the tree with the depth-first search technique. And for each of the nodes, we are going to also traverse the subtree with depth-first search technique, and we are going to find the sum and the number of elements in that subtree and return the value for that node. However, this is a very, very slow approach and we can do better. We can solve this problem more efficiently by using post-order depth-first search, where we traverse left, then traverse right before we evaluate the current node. And each of those calls, for example, the call to the left is going to give us two things, the total and also the number of nodes in that subtree. The right is going to do the same. It's going to give us the total and the number of elements in that subtree. Now we can use these values to calculate the average for the current node, where we are going to add each of all the totals plus 1 and all the number of elements plus 1 and find the average. So now let's write the code. First, we're going to define our count variable, and then we'll define our DFS function. This function will help us traverse the tree from the roots. Next, we will enter the definition of our DFS function and handle the base case, ensuring that when the node is null, we return an array of 0, 0, which stands for the sum of nodes in the subtree and the number of nodes. Then we'll call the left node recursively with the DFS function. This will help us to get the sum of elements on the left as well as the number of elements on the left. And because this is a post-order traversal, we are going to call the right node recursively using the DFS function. This will enable us to get the sum of elements on the right as well as the number of elements on the right. Next, we will calculate the total sum of elements in the subtree, including the current node. Similarly, we'll calculate the number of elements in the subtree by adding 1 to the number of elements on the left and the number of elements on the right. And then we check if the average is equal to the value of the current node. If that is true, we increase the count. And then we return an array holding the sum and the number of elements for the current node. And then finally, we return the count. Thank you for watching this tutorial and see you in the next.